Hello students, welcome to engineering geology classes. In today's class, we will discuss about the dam, the different structures on which the dam is constructed and what are the precautionary measures taken for while constructing a dam and how to select a site for a dam. So let us begin with the definition of a dam. So we have seen there are many types of dams in India, like in Karnataka also we have very near to Belgaum is Hidkal Dam. Okay, then we have KRS Dam. Okay, then these are a few examples of dam. So what is a dam actually? Dams are the structures or the barriers which are constructed across the river. Okay, what is a dam? Dam is a structure or a barrier, and how it is constructed? It is constructed across the river. For what purpose? To store the water for human requirements. So that is a definition of a dam. Dams are the structures or barriers which are constructed across the river to store water for human requirements. So dams are constructed for various purposes, like for providing water for irrigation. Then even the dams are multi-purpose dams also, like along with the storage of water, they are used for generating hydropower energy, that is electricity, right? Then for domestic and industrial use, then even for flood control and navigation, these dams are used. So if a dam serves more than one requirement, it is called a multi-purpose dam. Like for example, Nagarjun Sagar Dam, Krishnaraj Sagar Dam, Tungabhadra Dam. These are the examples of dam. So let us see the different parts of a dam. Okay, so here in the image you can see there is a dam. Okay, so here the first is inspection gallery or drainage gallery. Okay, wherein you can go inside. Okay, and it is meant for the inspection purpose. Okay, so that is a gallery which is an opening within the dam for observing its performance. Okay, then this is a dam. Okay, and this part of the dam is called as the upstream side of the dam, and this is the downstream side of the dam. So the water gets stored in the upstream side of the dam. So this is the path of the river. The river is flowing in this way, and we have constructed a dam across the river. Okay, so this part is upstream side and this is the downstream side of the dam. Then so upstream and downstream is over. Then this part, okay, where the maximum pressure of the dam will be there. Okay, that is the heel and toe of the dam. Okay, so heel is this one. Okay, heel of the dam is the portion of a dam that touches the ground on the upstream side. Okay, that is called as the heel, and toe is the part of the dam which touches the ground on the downstream side. So that is a toe of the dam. Then next is this part where the water is stored, that is called as the reservoir or storage reservoir. Okay, then there are spillways. Okay, this is a spillway. What is the role of spillway? It is a concrete structure which is made to discharge the excess water or surplus water, okay, from the storage reservoir. So if the water, the storage in the reservoir is exceeded, then that excess water is sent on the downstream side through the spillways. So that is called as a spillway. So through spillway and gates, the flood water can pass through safely without causing any damage to the dam. Then this topmost portion of the dam is called as the crest of the dam. Top of the dam is called as the crest of the dam. Then there are walls, parapet walls, which are placed along the top of the dam for safety of to a road or a walkway. Okay, so this is the parapet wall. Then this is the maximum water storage in the reservoir. Okay, the highest elevation up to which the water can be stored in the reservoir, that is called as the maximum water surface. Okay, then there is a dead water surface here. So dead water surface, this is the limit up to which the water has to be present. Okay, so the elevation of the water in the reservoir, if the water goes below this, okay, then you cannot withdraw the water below this level. So the water stays permanently up to this height. So that is called as the dead water surface. So that is a dead water surface. Then there are sluice gates also. So the sluice gate, this is the sluice gate. Okay, that is a part of dam. Okay, sluice gate, it is a gate these sluice gates, they control the water levels and the flow rates in the river and the canal. So it is a gate which can be opened through the grooves which are provided. Okay, it is made up of a metal or a wood. So usually it is made up of a metal. So these are the different parts of a dam. Okay, then the main part, that is the foundation of the dam, we are going to discuss about it in detail when we deal with the site selection of the dam. So next, how to select a site for a dam. So dam site, there are different parameters which we need to take into account before constructing a dam. So the first one is existence of a narrow valley. So if there is a narrow valley which is present, because we construct a dam where there is a valley. So here this is a hill and the river is flowing in this valley. Okay, so if the valley is narrow, how it is helpful? This can be blocked with a relatively smaller dam, and as a result, what will happen? The cost of the construction of the dam will also reduce, because we are constructing a narrow dam in a narrow valley. So if the valley is wider, then you have to construct the bigger dam, and obviously the construction of cost will be again high. So this is how the narrow valley selection is the most important step in the site selection for a dam. Then next is occurrence of bedrock at shallow depth. So what is that? So the dam foundation, okay, or to ensure the safety and stability of the dam, we have to see that the dam is resting on a very strong and stable rock. So if such competent rocks or a strong rock occurs very near to the surface or shallow depth, then it is very good site, because the cost of foundation of the dam will be less. But if the hard and strong rock, because it has to withstand the weight of the dam, okay, so this, if it occurs at great depth, then the foundation will have to be very high, and this involves again extensive work of excavation, the loose overburden, and we have to fill it by concrete. So this increases the cost. So if it occurs at shallow depth, then this is the suitable site for the construction of a dam. Then the third point is occurrence of competent rock for safe foundation. So Occurrence of competent. Here the word competent means the hard rock. Okay, occurrence of hard rock for the safe foundation. So the rocks which are present in the vicinity of the dam, that has to be checked. So the stability of the site for a dam foundation, it depends upon the rock types which are present at the dam site. So we have to also see the extent of weathering the rocks have undergone, that is the disintegration and decomposition of the rocks, and even we have to see the occurrence of intrusions, then fractures, folded rocks. Okay, so occurrence of the geological structures, if they are there, then that will again reduce the strength of the rock because they undergo weathering very easily. So such rocks, the rocks which are present at the dam site, they should be competent rocks, that is the hard rock. Then the presence of proper geological structures. So this is again very important for the safety or stability of the dam. The occurrence of favorable structures like there should not be any faulted zone or folded rocks. Okay, if there are rocks, how to select a proper site for the dam? So to select or reject a site for a dam, the location depends upon not only on the rock type but also the associated geological structures. In the previous class we have discussed regarding different types of folds, faults, joints, unconformity. So if such structures are present at this site, then how the care should be taken better to reject such sites with the structural disturbance. If it is more, then we have to reject such sites. So these are the few important points which we have to take care when we select the site for dam. Then there are few points like the abutments of the dam, that is abutments means suppose this is a valley and this is a dam, so the maximum load will be on the abutment. So this is the abutment, that is the sloping sides of the valley, that is called as the abutment. So the rocks which are present at the abutment side, they also should be strong. Then the valley slopes should be stable, and whenever the reservoir is full, because there will be a maximum load which is acting on the dam. Okay, so we have to take care about the different geological structures when we select a site for dam. Then there are different types of dams, like we have gravity dam, wherein the first image what I had shown you, that is an example of a gravity dam. Okay, so gravity dam is a massive structure that is based on the construction material which is used for the construction of dam. There are different types of dams. So the gravity dam, it is a concrete dam. Okay, so concrete dam, it is made up constructed in concrete. So if the height of the dam is about 60 to 70 meter, then it is concrete or masonry structure, then such type of dam is called as a gravity dam, and it is a triangular in shape. Okay, which stands by its own weight, that is important. So it is called as the gravity dam. So a good foundation rock is required for the construction of gravity dam, that is this type of dam. Okay, then we have one more type of dam, that is called as buttress dam. So this dam will have a deck, sloping deck. Okay, and struts are provided for its support. Then we have arc dam, which is in arc shape. Okay, so the abutments rocks that should be very strong in case of a arc dam, because the maximum load will be on the abutment. So that is a arc dam. Then we have earthen dam. Okay, so the Hidkal dam is partly gravity dam and partly earthen dam. So earthen dam, they are made up of the earth material, that is the soil is used. Okay, and then the rock fill is used. Okay, hard rock that is fill at the center with the rock and on the sides by the soil. So these are the different types of dams. Then the very important concept which we need to understand before we go for the different structures present at the dam is the forces acting on the dam. The forces acting on the dam. So the any major dam, if that is a highly complex engineering structure, right? So where more than one type of forces which come into play. So we have to do a proper estimation and analysis of all these forces which are essential to ensure the stability of dam. So what are those forces which are acting on the dam? So the first one is the water pressure. So in here, this is the direction in which the water pressure is active. So you can call it as T. So T is what? The water pressure. So the pressure of the reservoir water. So that tends to displace the dam horizontally. So the water which is present in the reservoir, what it does, it try to displace the dam in a horizontal direction. Then this is the self weight of the dam, that is W, the weight of the dam which acts in the downward direction, and it will try to key the dam in position. And the resultant of these two forces, that is W and T, that is called as the R. So R is the resultant of the forces of T and W. So T is the water from the reservoir, the pressure, water pressure, and W is the weight of the dam. So this R, which indicates that when the reservoir is full, the toe of the dam is overloaded, that is this portion is heel and this is the toe. So when the reservoir is full, okay, when it is overloaded, then this portion, that is the toe of the dam, this is the toe of the dam and this is the heel of the dam. So toe of the dam will be under or it is overloaded and heel will be relieved when the reservoir is full. So therefore, in order to make a dam stable, the ratio T by W, okay, that has to be kept smaller while constructing the dam. Then there is one more force which is acting on the dam, that is called, this is regarding the water pressure. Then the one more pressure acting on the dam is the pore pressure. Pore pressure. So the water which is entering in the permeable rock below the dam, that exerts an upward pressure. So water which is entering in the permeable rocks, okay, that exerts an upward pressure below the dam. So this exerts an upward pressure on the base of the dam. So this pressure, which is equivalent to the hydrostatic pressure, so it is called as the pore pressure, or it is also called as the uplift pressure. Pore pressure or uplift pressure. So it acts against the weight of the dam and thus helps in sliding or overturning of the dam. So these are the forces which are acting on the dam. Pore pressure, that is, and uplift pressure or pore pressure and water pressure. Now we'll discuss the different structural features of the rock at the dam site. So there may be presence of igneous rocks, sedimentary rocks, or the metamorphic rocks at the dam site. So we have to select a proper type of rock for the rock dam foundation. Okay, so first we'll see the rocks if they are horizontal. So here the dam on horizontally bedded rock. So when the rocks are horizontal, the excavation at the dam site should be carried out till we get the hard and strong rock. So here this is the dam. The gravity type of dam is represented like this. Okay, so this dam, okay, here these are the forces acting on the dam, that is the T, W, and resultant of these two, that is the R. So these are the forces acting on the dam. So here, for if the rocks are horizontal, you can see the rocks are horizontal. So if such site is present, then we have to see that till we get the hard, compact and non-porous rock, we have to do the excavation. So this situation is good at the dam site because the load of the dam that acts perpendicular to the bedding plane, which means that the beds are in position to bear the load of the dam. Okay, so there are less chances of sliding. Okay, then uplift pressure is effectively reduced. Then if the strata is composed of alternate hard and soft rock, because we know how the sedimentary rocks are formed, they are not same always, right? So if there is a alternate hard and strong rock present, then hard and soft rock present, then such site should be undesirable. Otherwise, if it is made up of all same type of rock, suppose for example sandstone, okay, then such site will be a very good site for construction of a dam, that is on the horizontal beds. Then next is, if the rocks are dipping, that is if the rocks are inclined. So when the beds are inclined, it is better to have the length of the dam across the bedding plane or the strike, so that the weight of the dam is spread over a wider area. If the rocks are inclined, what care we should take is the length of the dam should be across the bedding plane. It should not be along the bedding plane. Okay, the length of the dam. So there are different cases, like in different directions the beds are dipping. So the first case wherein the beds are dipping in the upstream side. So you can see, yes. So here this is the upstream side of the dam, okay, and this is the downstream side of the dam. And how these beds are dipping? These beds are dipping towards the upstream side. Okay, so when the beds are dipping upstream, it is a safe situation. So why? Because you can see the resultant of the T and W, how it is acting perpendicular to the bedding planes, right? So the bedded rocks, they are stronger in compression and they can bear the stresses when applied, okay, normal to the bedding plane. So they are the most capable of supporting the weight of the dam and the pressure of the reservoir. So because the resultant of these two forces, that is the forces, that is the water pressure, that is T, and the weight of the dam, and R is the resultant of those two forces. So the resultant force, that is at right angle to the bedding plane of the rocks. So thus what happens, the beds which are dipping gently towards the upstream side, they offer best resistance to the resultant, that is R, and they obstruct the leakage of the water. Okay, that is, suppose if there is any leakage along the bedding plane, then this water will be circulated back to the reservoir. It will not go on the downstream side. So that is one advantage. So if the beds are dipping in the upstream direction, okay, so even if there is some leakage, the water will be again circulated towards the reservoir along the bedding plane. So bedded rocks are stronger in compression, okay, and greater stress when it is applied normal to the bedding plane. So they are the best suited for construction of dam. Then if the beds are dipping on the downstream side, that is in the next case, right? You can see here the beds are dipping on the downstream side. So this is the upstream side of the dam and this is the downstream side of the dam, and the beds are dipping in the downstream direction. So the dams which are constructed on the rocks which are dipping in the downstream direction, they may not be safe. So the reasons of being not safe are, if there is a percolation of water, what will happen? The percolation of water through the strata, it dissolves the cementing material of the rock, and there are chances that enlarges the openings by erosion, that is mechanical erosion. So what happens? This will decrease the strength of the rock and it will increase the seepage of the water. So there will be more seepage if the water is reactive with the cementing material, and if the water which enters into the openings of the rock below the dam, that causes an uplift pressure. So this will tend to decrease the stability of the structure. So this water which is entering through the bedding plane, it will cause an uplift pressure on the dam. Then it decreases the stability of the dam. Then if you see the resultant of W and T, how it is? It is along the bedding plane. You can see in the previous case, the R was perpendicular to the bedding plane, and here the R is along the bedding plane. So the resultant of weight of the dam and the pressure of the reservoir water, so the resultant it acts parallel to the bedding planes. So this endangers the stability of the dam. That is, the dams may undergo sliding along the bedding plane. Okay, and there is if the water which is percolating through these bedding planes, here it gets recirculated to the reservoir, but here if there is a leakage, it will go on the downstream side. Okay, so the purpose of dam is what? To store the water, but here the water will not get stored. Then the next case is the dam on the beds which are vertical. So in nature, the occurrence of perfectly vertical bed is very rare. Okay, and it will cause some leakage, and if we take proper precautionary measures, then this site can be improved for the construction of a smaller dam. So these are the different structural features, okay, when the rocks are horizontal and inclined. Okay, so in inclined we have seen the different cases like beds dipping upstream side, beds dipping downstream side, and the beds are vertical. Then next is dam on folded rocks. So folds are the wavy undulations, right, which are developed in the rocks because of the forces acting on the rock. So if highly folded rocks are present, then that should be avoided. Such sites should be avoided. And if we adopt some precautionary measures, then you can have different cases here. Okay, you can construct the dam if you take the proper actions. So here there are two cases. One is dam on the anticline fold and other one is dam on the syncline fold. So first we'll discuss the dam on anticline fold. So here is the anticline. The two limbs, they dip away from each other. So such folds is called as the anticline fold. So it should be seen that the dam should rest on the upstream limb of the anticline. So here there are two limbs. This is one limb of the dam fold, and this is the other limb of the fold. So here, where to construct a dam? Among these two, which is safe? So this is one site and this is the other site. Here one is A and B. So if you study this properly, the R, that is parallel in this case, and here in this case the R, that is resultant is perpendicular to the bedding plane. So obviously it is similar to the dam on the beds which are dipping on the upstream side. So this is the safe situation for construction of a dam. Okay, so this is safe and this is unsafe in case of an anticline, because R is perpendicular to the bedding plane in case of A, right? And in case of B, R is parallel or along the bedding plane, so that is unsafe. Then if you see the dam on syncline fold, so syncline is like a basin. The two limbs of the fold, they dip towards each other. So if the dam is to be constructed on a syncline structure, it is comparatively safer to rest the dam on the downstream limb. So here it was safe on upstream limb, here it is safe on the downstream limb. Again you can study the same situation here. So here you can see the beds are dipping like this, and this R is perpendicular to this bedding planes. So this is safe and this is unsafe, because here again the beds are dipping like this. So here R is parallel to the bedding planes, right? So this is the safe side and this is not the safe. So there will be a seepage through porous rock to the reservoir basin only. So the dam which is resting on the upstream side, where R remains parallel to the bedding plane, can cause a leakage. So if there are folded rocks, okay, they are not only under strain but they are also physically fractured along the crest of the fold. So along the crest, the folded rocks will be under stress, so they are fractured along the crest or trough of the fold. So because of this, you have to provide grouting for such, that is, you have to seal those cracks if they are present, and other precautionary measures you have to take, and depending upon the site, okay, you have to improve the stability and competence of the rocks which are present at the dam site. So this is regarding the dam on folded rocks. Then next is dam on faulted and jointed rock. So dam on faulted rocks, so it is, first we'll see, this is a fault, there is a fault here, F dash represents the fault. So the rocks which are there here and here, they have undergone a displacement. So whether it is a good site, it is always better to reject the site for a dam in the faulted zone. The best example is Koina Dam, which is constructed on faulted zone. So I had told you fault is what? The displacement of the beds along the crack, right? So along this fracture, the beds have displaced. So this is a cause for earthquake, right? And because of that, this reason, again, if you construct a dam in faulted zone, there are more chances of again earthquake. So if a site has to be selected in such zone, you have to see that the site has very few disadvantages and there should not be any serious defects. So it is advisable in such cases that if you want to construct a dam in faulted zone, then it is better to place the foundation of the dam on the upstream of the fault. So here this is safe and this is unsafe, because here because this part has already gone down, and if you put more weight on that, because dam is very big structure which involves water pressure again, right, along with the self weight of the dam. So here if we construct a dam here, again there are chances that this again undergoes sliding, and if we take proper measure, and here one more problem is, along the fracture, the water which is stored in the reservoir, that will seep through that crack and again it will be dangerous. So we have to study the history of the fault also, right? that is the nature, how is the, what type of fault it is, the extent and the age of the fault. If we study and if we take proper measures, then you can do the grouting, you can seal that crack, then you can construct a small dam. Okay, and that too we have to construct on the upstream of the fault. Okay, so and if the rocks are jointed, okay, joints are what? Joints are cracks along which there is no movement. If there is a movement, then that is a fault. So if only cracks are present, that is again a very weak point in the structure. So if the site to be selected for the dam that is highly jointed, if there are many joints, many cracks are present, then we have to face the difficulties before, during and even the after the construction of the dam, because the presence of joints in the rocks that will cause the water leakage, right? There will be leakage of water through them, and with the passage of time, what will happen? These leakages may endanger the dam. So if the area affected by joint is very small, then you can do the grouting. Okay, that will improve the site. You can seal the cracks. So if the underlying rocks are heavily jointed, then we have to straight away reject the site for construction of a dam, because through those joints, through those cracks, the water will percolate and it will increase the uplift pressure on the dam. So we have to take care. Again, there may be, it may cause the sliding also, sliding of the dam. So we have to take care that the dam, if the rocks are highly jointed, then we have to straight away reject the site for dam. So these are the different cases which we have studied in case of dam construction. So in exam you may get question on individual cases, or they may ask all the cases for more marks. Okay, so we have to study each and every case, that is the dam dipping on the dam on the dipping beds, that is upstream dipping, downstream dipping, then dams on horizontal beds, dams on folded, that is anticline, syncline, there are again two cases in each, then dams on faulted and jointed rocks. So these are the different cases, the structural importance, okay, which will tell us the structural importance of the dam site. So thank you. This is a very important chapter from exam point of view. Thank you.